Today, today we will see Introduction to DSP Part 2. So first we will see basically what is analog and what is digital signals. So analog and digital signals are the type of the signals which carries the information. We have already seen that what is signal. Signal is nothing but which carries the information. So analog and digital signal are the types of signal which carries information. What is the basic difference between the analog signal and digital signal? The major difference between both the signal is that analog signals have continuous electrical signal while digital signals have non-continuous electrical signal. So the difference between analog and digital can be observed with various examples of different types of waves. Analog signal have continuous electrical signal while the digital signals have discontinuous electrical signal or non-continuous electrical signal. So first we will see what is analog signal. The analog signal were used in many systems to produce signal to carry the information. These signals are continuous in both value and time. The use of analog signal has been declined with the arrival of digital signals. In short, to understand the analog signal, all signals are natural or come from naturally are analog signals. And what is digital signals? Unlike the analog signals, digital signals are not continuous, but the signals are discrete in value and time. These signals are represented by binary numbers and consist of different voltage values. The next is difference between the analog and digital signal. Analog signals are continuous signals, digital signals are discrete signals. Analog signals are represented by sine wave and digital signals are represented by square wave. Examples of analog signal: human voice, natural sound, analog electronic device, and the examples of digital signals: computer, optical drives, and other electronic devices. Analog signals have continuous range of values, while the digital signals have discontinuous values. Analog signal records sound wave as they are, that is, it is in the original form, and digital signal convert it into the binary waveform. Analog signal used in analog devices, while the digital signals are suited for the digital electronics such as computer, mobile, and many more. Analog signal bandwidth is low, while the digital signal bandwidth is high. Analog signals are deteriorated by noise throughout the transmission as well as write-read cycle, while relatively a noise immunity system during the transmission process in digital and write-read cycle. Analog hardware never offers flexible implementation, while the digital hardware offers flexibility in the implementation. Analog signal, it is suited for audio and video transmission, while digital signal, it is suited for computing and digital electronics. In analog, processing can be done in real time and consumes less bandwidth compared to a digital signal, while in digital, it never gives a guarantee that the digital signal processing can be performed in real time. Analog instruments usually have a scale which is cramped at lower end and gives considerable observational errors, while in digital instruments never cause any kind of observational errors. Analog signal doesn't offer any fixed range, while the digital signal has a finite number, that is 0 and 1. There are some advantages of analog signal, that is, it is easier in processing, it is best suited for audio video transmission, it has a low cost and is portable, it has a much higher density so that it can present more refined information, not necessary to buy new graphic board, use less bandwidth than digital sound, provide more accurate representation of sound. It is a natural form of sound. Advantages of digital signal. Digital data can be easily compressed. Any information in digital form can be encrypted. Equipment that uses a digital signal is more common and less expensive. Digital signal makes running instruments free from observation and errors like parallax and approximation error. A lot of editing tools are available. You can edit the sound without altering the original copy. It is easy to transmit the data over network. Now there are some disadvantages of analog signal as well as digital signal. First, disadvantages of analog signal. Analog have a lower quality signal than digital. The cables are sensitive to external influence. Cost of analog wire is high and not easily portable. Low availability of the model with digital interface. Recording analog sound on the tape is quite expensive if tape is damaged. It offers a limitation in editing. Quality can be easily lost. Data can become corrupt. Plenty of recording devices and format which can become confusing to store a digital signal. The next is disadvantages of digital signal. Sampling may cause a loss of information. Analog to digital converter and digital to analog converter. These two converters demands a mixed signal hardware. Processor speed is limited. It develops a quantization and round off errors. It requires a greater bandwidth. System and processing is more complex. So these are some of the disadvantages of the digital signal. Next is basic elements of signal processing system. So first diagram is analog signal processing. In that, analog signal processor input of analog signal processor is analog input and its output is also in the form of analog. While in digital signal processing there are three blocks. First one is analog to digital converter, second one is digital signal processor, and the last one is digital to analog converter. So here input to the system is analog and it is given to analog to digital converter, which convert the analog signal into the digital signal. Then it is passes through the digital signal processor. Then digital data is again given to the D to A converter and output of this system is analog output signal. Next is signal characteristics. So signals are physical quantities. Signal can be measurable. Signals are analog and signal contain the information. For example, temperature, pressure, mass, speed, acceleration, torque, voltage, current and power. So while studying signal, there are some terms which may know us. So the first one is magnitude. So what is magnitude? It generally refers to the maximum value of the signal. Next is range. What is range? It is the difference between maximum and minimum values of the signal. The next is amplitude. Amplitude means it is an indicative of signal fluctuations relative to the mean. Frequency. It describes the time variation of signal. Next is dynamic. Dynamic means signal is time varying. Static. Signal does not change over the time period of interest. Next is deterministic. Here the signal can be described by an equation. Non-deterministic means describes a signal which has no pattern of repetition and cannot be described by a simple equation. Next is mean. Mean means what? Average or static portion of the signal over the time of interest. RMS, that is root mean square. It is nothing but the average value of the square of the signal over the time of interest. Next is classification of signal. First one, deterministic signal. So a deterministic signal behaves in a fixed known way with respect to time. Thus it can be modeled by a known function of time t for continuous time signals, or a known function of sampler number n and sampling spacing t for a discrete time signal. Next is random signals. In many practical situations, there are signals that either cannot be described to any reasonable degree of accuracy by explicit mathematical formulas, or such a description is too complicated to be of any practical use. The lack of such a relationship implies that such a signals evolve in time in an unpredictable manner. So we refer to this as a random. Next is even and odd signals. A continuous time signal, say x of t, it is said to have an even signal if it satisfies the following condition, that is x of minus t equal to x of t for all the values of t. The signal x of t is said to be odd if it satisfies the following condition, that is x of minus t equal to minus x of t. In other words, even signals are symmetric about the vertical axis or the time origin, that is here first diagram is shown, whereas odd signals are asymmetric about the time origin. Similar remarks apply to the discrete time signals. Next is periodic signal. A continuous signal, say x of t, is periodic if and only if there exists a time t greater than 0 such that x of small t plus t is equal to x of t. Now what is that capital T? It is nothing but the period of the signal in units of time. So we already know that frequency f is equal to 1 by t, that is reciprocal of t. So frequency of the signal in hertz. The W is equal to 2 pi upon t, which is the angular frequency in radians per second. The discrete time signal x of nt is periodic if and only if there exists an n greater than 0 such that x of nt plus n is equal to x of nt. Now what is capital N? It is nothing but the period of the signal in a number of sample spacing. So a signal is a periodic signal if it completes a pattern within a measurable time frame called as a period, and it repeats the pattern over identical subsequent period. The completion of full pattern is called as a cycle, and a period is defined as the amount of time in second is required to complete one full cycle. Next is energy and power signals. So the terms signal energy and signal power are used to characterize a signal. They are not actually measure of energy and power. The definition of signal and power refer to any signal x of t which includes signal that take on complex values. So a signal is referred as an energy signal if and only if the total energy of the signal satisfies the condition E is in between 0 and infinity. On the other hand, it is referred to as a power signal if and only if the average power of the signal satisfies the condition, that is P is in between 0 and infinity. So an energy signal has a 0 average power, whereas a power signal has infinite energy. So the periodic signals and the random signals are usually viewed as a power signals, whereas the signals that are both deterministic and non-periodic are energy signals. So finite energy signal will have a zero total power. When energy is finite, the total power will be zero. When the limit n goes to infinity, the energy dilutes to zero over the infinite duration, and hence the total power becomes zero. While in power signals whose total power is finite and non-zero, the energy of the power signal will be infinite. For example, periodic sequence like sinusoidal wave. A sinusoidal signal has a finite non-zero power but infinite energy. So a signal cannot be both an energy signal and a power signal. The next is converting analog into digital. The simplest form of conversion, that is ADC, uses a resistance ladder to switch in the appropriate number of resistors in series to create the desired voltage that is compared to the input voltage. So here a ladder with resistor, that is resistor ladder, is used. The output of the resistance ladder is compared to the analog voltage in the comparator. So there are two inputs to the comparator. One is analog voltage and the second one is output of the resistance ladder. So when there is a match, the digital equivalent, that is switch configuration, is captured. The analog voltage can be compared with digitally generated voltage in the comparator through a technique called binary search. The digitally generated voltage is adjusted in steps until it is equal to the analog voltage. When the two are equal, the digital value of the voltage is outcome. So ADC follow a sequence when converting analog signal to digital. They first sample the signal, then quantify it to determine the resolution of the signal, and finally set binary values and send it to the system to read the digital signal. Two important aspects of ADC are its sampling rate and the resolution. The ADC's resolution can be tied to the precision of the ADC. The resolution of the ADC can be determined by its bit length. So, use a DSP processor when the following conditions are required. That is, the first condition is cost saving. When cost saving is required, you can use a DSP processor. Smaller size. Third one is low power consumption. Next is processing of many high frequency signal in the real time. So these are some of the conditions, you can say, to use the DSP processor. Thank you.